Take a booklet there, Skylar. Okay, so this next chapter is on relations and functions. And as the title page shows, it's going to involve looking at some graphs. So the first thing we need to review is a Cartesian coordinate system. Is a coordinate system that specifies each point uniquely in a plane by a pair of numerical coordinates. It's how we graph points and graphs on a grid.
What we're going to do in this video is, through a bunch of examples, familiarize ourselves with the XY coordinate plane. And first we're going to just look at some points that are already plotted and figure out their coordinates. Then we're going to look at some coordinates and figure out where those points are, and then we'll do one more problem. So let's figure out what are the coordinates of these points. So you have this point right here, A. So it's x coordinate. You can see it right there. You just drop down. Where does it intersect the x-axis? X is equal to 5. So it's the point 5, comma, and y is going to be equal to 6. 5, comma, 6. Now this point B here, what's the x-coordinate? It is 5 to the left. 5 to the left of the x-axis. This is negative 5. X-axis, x-coordinate is negative 5. Y-coordinate is, if you just go straight to the right, you're going to hit y is equal to 5. Y is equal to 5. Let me switch colors. C. I think you're getting the hang of this. Let's do the y-coordinate first. The y-coordinate is 3. You see that right there. And then the x-coordinate is negative 2. Negative 2. You always put the x-coordinate first. That's just the convention we use. D. X-coordinate, negative 2. You see that right there. Y-coordinate, negative 2 as well. Let me get another color. E. Let's do the y-coordinate. Well, we'll figure it out first, but you always have to write it second. It's negative 4. You see that right there, the y-coordinate. The x-coordinate is 3. And then finally F. The x-coordinate is 2. And the y-coordinate is negative 6. Hopefully that gives you a sense of at least figuring out the coordinates. Now let's go the other way. Let's start with coordinates and figure out where those points are. So you have this first one. I'll do it lowercase a in parentheses to differentiate it from this uppercase a. So it's at 4, comma 2. X is equal to 4. Y is equal to 2. X is equal to 4. Y is equal to 2. So that's that point right there. Let's do the next one. Let me do it in a color that you'll be able to read. B. X is equal to negative 3. X is equal to negative 3. Y is equal to 5.5. So you go all the way up to 5.5. Right? Y is equal to 5.5. So that is the point lowercase b with parentheses around it. Then C. 4, negative 4. X is equal to 4. Y is equal to negative 4. Right over there. And then one last one, I'll do it in orange. D. X is negative 2, y is negative 3. X is negative 2, y is negative 3 right there. That's the D with parentheses. And you could have gone the other way. You could have said, hey, y is equal to negative 3, x is equal to negative 2. So you could go to the left and down, or you could go down and to the left, and you're still going to get to the same point. So hopefully that gives you a good sense of how to figure out coordinates, or if you're given coordinates, how to figure out where to plot something on the XY coordinate plane. Now let's do a slightly more involved problem. So it says the following 3 points are 3 vertices of square ABCD. Plot them on a graph, then determine what the coordinates of the 4th point D would be. All right, let's plot these on a graph as they tell us to do. All right, that'll be my y-axis. That's my y-axis, the vertical axis. That'll be my x-axis. And let me mark it so that's x equals 1, 2, 3, 4. This is x is equal to negative 1, negative 2, negative 3, negative 4. That's y is equal to 1, 2, 3, 4. This is y is equal to negative 1, negative 2, negative 3, negative 4. I could write that as y equals 4. That's y equals negative 4. X is equal to 4. X is equal to negative 4. And see, let's plot these points. So first we have the point A is equal to negative 4, negative 4. So we go x is negative 4, and then y is negative 4. So we drop down 4 right there, and that is our point A, negative 4, negative 4. And just to familiarize yourself with a labeling scheme that you may or may not have seen before, is that people label these sections of the coordinate plane. They call this the first quadrant. They call this the second quadrant. They call this the third quadrant. And they call this the fourth quadrant. And these are just the Roman numerals for 1, 2, 3, and 4. So this point is in the third quadrant. When we looked up at this stuff over here, these points are in the fourth quadrant. These are in the third, second, first. Just an interesting thing to know. Sometimes someone might ask you, what quadrant does that point in? And you just say, oh, okay, I see. If they're both negative, they're going to be in the third quadrant. If just the y is negative, but the x is positive, you're going to be in the fourth. If they're both positive, you're in the first. If y is positive, but x is negative, you're in the second. And we'll talk a little bit about that as we plot these points. So point B, x is positive. It's 1, 2, 3. And y is negative 4. So we drop down here into the fourth quadrant. That is the point B. It's 3, negative 4. So we can already see the bottom of our rectangle that they're talking about right there. And notice, both of these have the exact same y. They're both at the same level below the x-axis. And then what's the next point? Point C is 3, 3. So 3, 3. It's in the first quadrant. Both of its coordinates are positive. 3, 3. Both x and y are positive. And notice, it's on the same vertical as B. It has the same x value. They both have an x value of 3, so it's right above it. Right above it. Now we have to figure out the last point here. Well, the point is going to have to be on the same vertical as this point. It's going to have to be on the same vertical as this point, which means it's going to have the same x value as this point. So the x value is going to be negative 4. And then it's going to have to be on the same horizontal as this point. It's going to have to be on the same horizontal as that point. So it's going to have the same y value. It's at the same height above the x-axis. So it's going to have to be 3. So that is our point D. Notice it's at negative 4, right above A, and it's at y is equal to 3, right to the left of point C. And we are done. What we're going to do in this video.
Okay, so that's an introduction into the coordinate system, how we label points on a graph. Right, so on this grid, and notice that the x-axis is always the horizontal axis, the y-axis is always the vertical axis. When we write points, it's always in the order x first, y second. And the way to remember that is that it's alphabetical. Okay, it's alphabetical. So to plot the point 2, 4, the x value is 2. The y value is 4. X tells you if you go left and right and how far. Because x is positive 2, that means you're going to go 2 to the right. The y value tells you if you go up or down and how far. A y value of positive 4 means you're going to go 4 up. So you've got two numbers there, 2, 4, but they give you 1 point. Not two separate points, 1 point. It just takes two different movements to get there. The first movement is left to right, which the x value tells you. The second movement is up or down, which the y value gives you. So there's point A, and we label it. Point B is the point -5, -1. So again, the first number tells you the x value, if you go left or right and how far. Because x is -5, that means you're going to go 5 to the left. But then you also have to go 1 down because your y value is -1. So there's the point -5, -1. Point C, again, the first number is the x value, the second number is the y value. It's alphabetical. X comes before Y in the alphabet. If X is -4, that means we're going to start by going 4 to the left. And Y is +4, that means we're going to go up 4. So again, there's two numbers there. There's two movements we make, but it's only a single point. It just takes two movements to get there. And as I said in the video, you could have done the Y value first. A Y value of 4 means you go up 4, and then an X value of -4 goes to the left 4. It's the same point. Normally we do X first, Y second, but you don't have to. You don't have to. So the last point, X is +3, so you're going to go 3 to the right. Y is -2, which means you'll go down 2. So there's point D. And as he said in the video, this is the first quadrant where they're both positive. If you work your way around counterclockwise, this is how the quadrants are labeled. And the reason they're labeled this way is when mathematicians first started using something called trigonometry, which we're going to learn about. It's working with right triangles. It's finding angles in triangles and finding missing sides in right triangles. They started by talking about the sun rising and then falling. And if you think of this coordinate system as a map, north is up, south is down, east is to the right, west is to the left. The sun rises in the east. This is the path that the sun follows. It rises in the east, so that's the first part of the sun going up. That's the first quadrant. And it continues on and it sets in the west. That's the second phase of the sun. That's the second quadrant. And then they just extended it into going through all four quadrants, which the sun really does go around the whole world. Actually, it's the world going around the sun, but you get the idea. But that's where the whole idea of naming the quadrants came from. All right, so try those your turn points on your own. Plot them on the graph, and then we'll check them. Point E is -3, 0, which means you go 3 to the left, but you don't go up or down. That point is on the x-axis because you don't go up or down. The y value is 0. What do we do for the next one, Lena? We already did that one when you were checking your stock market. So the next one, x is 0, which means you don't go left or right. Y is +6, though, so you're going to go up 6. So there's point F up there. This one is on the y-axis because x is 0. You don't go left or right. G, 0, -1 means you don't go left or right. You just go down 1. Again, this one is on the y-axis. There's point G. And H, 7, 0 means you go 7 to the right. Because the y value is 0, you don't go up or down. So these points are on or in no quadrants. Okay? Because to be in a quadrant, you can't be on one of the axes. That last one, point H, is between quadrants 1 and 4. But it's not in any quadrant because it's on one of the axes. And then these next ones, working backwards, we are given the point and you want to write the coordinates. Remember, it's always x first, y second. You go left or right first, then you go up or down when you're writing down the numbers. So point M, you go 4 to the left and up 5. Because you're going 4 to the left, x is -4. That means 4 to the left. And then up 5, so the y value is +5. Point N, you don't go left or right to get there. The x value is 0. But you will go up 3 units, so the coordinates are 0, 3. It's on the y-axis, so you don't go left or right. Hence, the x value is 0. Point P, to get there, and it doesn't matter what order you do it, but you got to write them in the same order, always. I mean, the x value first, the y value second. We could do the y value first by going up 2, but that's the second number that's written down. The x value is found by going 3 to the right. So no matter what way you do it, it has to be in that order. It has to be in that order. What about the last one, Hannah? Agree with that, Kira? Yes, because you're going 2 to the left. That's why x is negative 2. You don't go up or down. And because of that, y is 0. Okay, so write the coordinates of those last 4 points. What did you say for point R, Danny? You agree with that, Charlie? Okay, good. What about the next one, Keen, point S? Is that right, Kate? Yep, good. Point T. Where's that, Wayne? Is that right, Alicia? Good. It's at the same height as point S. And because of that, the y values are the same. Let's grab a booklet there. Beckham, what about point U? You agree with that, Kyler? Yes, the y value should be negative 4, not negative 5. Okay? So as we said, points can either be in an axis or on an axis or in a quadrant. So it asks us to identify if it's in a quadrant, which quadrant it's in, or if it's on an axis, which axis it lies on. The point 0, 3. And we can look up top here at the graph and kind of see where that would be. That's point N. It is not in a quadrant. It is between two quadrants. Yes, it is. It is on the y-axis. So that's what you would write for that one. -2, -1. So we don't have that point on our graph up here, but it would be right there. You go 2 to the left and 1 down, which puts us in quadrant 3. Again, you start with 1 in the upper right, and then you go counterclockwise around. This is in the third quadrant. We'll say Q3 for quadrant 3. -3, +6, that means you go 3 to the left and up 6. That'll put you in quadrant 2. Quadrant 2. And 4, 0 means you go 4 to the right. You don't go up or down, which would put us on the x-axis. Right, so do those next 4 on your own, please. Negative 10 comma 0 means you go 10 to the left, you don't go up or down. That'll be on the x-axis. 14 comma 3, you go 14 to the right and up 3. This will be in quadrant 1. 0, negative 6, you don't go left or right, you just go down 6 units. That puts us on the y-axis. And 4, negative 7, 4 to the right and 7 down. That'll put us in quadrant 4. So before we begin this topic, we need to discuss some important terminology. A linear relation is a relation whose plotted points lie on a straight line. If we talk about interpolation, it's estimating a value between two known values. But extrapolation is where you predict the value by extending a pattern beyond the known values. We have two different types of data that we talk about. Discrete data can only take certain values. For example, the number of students in a class. You can't have half of a student, so no decimals or fractions if it's discrete data. Continuous data is where you can take any value within a range. For example, a person's height could be any value within the range of human heights, not just certain fixed heights. Time in a race, you can even measure it to fractions of a second, etc. So we're going to be talking about discrete data, which can only be certain values, not the values in between, and continuous data that can take values in between the points that you have.
Find the slope of the line in the graph. And just as a bit of a review, slope is just telling us how steep a line is. And the best way to view it, slope is equal to change in y over change in x over change in x. And for a constant, this will for a line, this will always be constant. And sometimes you might see it written like this. You might see this triangle. That's a capital delta. That means change in y over change in x. That's just a fancy way of saying change in y over change in x. So let's see what this change in y is for any change in x. So let's start at some point that seems pretty reasonable to read from this table right here, from this graph. So let's see, we're starting here. Let me do it in a more vibrant color. So let's say we start at that point right there, and we want to go to another point that's pretty straightforward to read. So we can move to that point right there. We can literally pick any 2 points on this line. I'm just picking ones that are at nice integer coordinates, so it's easy to read. So what is the change in y and what is the change in x? So first let's look at the change in x. So if we go from there to there, what is the change in x? My change in x is equal to what? Well, I could just count it out. I went 1 step, 2 steps, 3 steps. My change in x is 3. And you can even see it from the x values. If I go from negative 3 to 0, I went up by 3. So my change in x is 3. So let me write this. Change in x, delta x is equal to 3. And what's my change in y? Well, my change in y, I'm going from negative 3 up to negative 1. Or you could say 1, 2. So my change in y is equal to positive 2. So let me write that down. Change in y is equal to 2. So what is my change in y for a change in x? Well, when my change in x was 3, my change in y is 2. So this is my slope. And one thing I want to do, I want to show you that I could have really picked any 2 points here. Let's say I didn't pick, let me clear this out. Let's say I didn't pick those 2 points. Let me pick some other points, and I'll even go in a different direction. And I want to show you that you're going to get the same answer. Let's say I view this as my starting point, and I want to go all the way over there. So what is well, let's think about the change in y first. So the change in y, I am going down by how many? How many units? 1, 2, 3, 4 units. So my change in y in this example is -4. I went from 1 to -3. That's -4. That's my change in y. Change in y is equal to -4. Now what is my change in x? Well, I'm going from this point, or from this x value, all the way, let me do that in a different color, all the way back like this. So I'm going to the left, so it's going to be a negative change in x. And I went 1, 2, 3, 4, 5, 6 units back. So my change in x is equal to -6. Change in x is equal to -6. And you could even see I started at an x is equal to 3, and I went all the way to x is equal to a -3. That's a change of -6. I went 6 to the left, or a change of -6. So what is my change in y over change in x? My change in y over change in x is equal to -4 over -6. The negatives cancel out, and what's 4 over 6? Well, that's just 2 over 3. So it's the same value, you just have to be consistent. If this is my start point, I went down 4, and then I went back 6. -4 over -6. If I've used this as my starting point, I could say that I went up 4, so it'd be a change in y would be 4, and then my change in x would be 6. And either way, once again, change in y over change in x is going to be 4 over 6, 2/3. So no matter which point you choose, as long as you kind of think about it in a consistent way, you're going to get the same value for slope.
Okay, so that's an introduction to slope. It's known as the rate of change. It describes how one quantity changes in relation to another quantity. If x is the independent variable and y is a dependent variable, then the rate of change is change in y over change in x. So we will talk about independent and dependent variables a little bit later on. But it doesn't change the fact that the rate of change, which is what slope is the change in y over change in x. And as I said in the video, rates of change can either be positive or negative. This would correspond to an increase or decrease in y, the y values between two data points. When a quantity does not change over time, it is called a zero rate of change. So that example we just saw was a positive rate of change because as x increased, y also increased, or the graph slanted upwards. As we go left to right, the line is rising. That's a positive slope or a positive rate of change. But if y decreases as x increases, that means as you go left to right, the line is falling. That is a negative rate of change or a negative slope. If the y values remain constant as x increases, then that is a zero slope, a zero rate of change. So in this example, it says wakeboarding has grown to be a popular water sport. The graph shows the distance that a wakeboarder is from their starting point on this last mountain lake in Saskatchewan. Describe the rate of change for each section of the graph below as positive, negative, or zero. So if the line is rising as you go left to right, that is a positive rate of change. Okay, section A is a positive rate of change because it's rising as you go left to right. Now, section B is also rising as you go left to right. It's just a little steeper. So that means y is changing at a faster rate as x increases. Y is increasing at a faster rate as x increases. Section C is a zero rate of change. So that means the distance from the start isn't changing. So probably that means that the person on the wakeboard is stopped. Maybe they wiped out. Okay. D is another section where the rate of change is positive. And that's the steepest part, it looks like, which means again that its distance from the start is at a much quicker rate. The slope would be a higher number. Point E, though, now they're getting closer to the start. And so that is a negative rate of change because the line is falling as you go left to right. F, the rate of change is 0. The distance from the start is not changing, the time is, but the distance from the start stays constant. Again, it probably means that for whatever reason, they've stopped. And then at point or section G, again, it's a negative rate of change, which means they're getting closer to the start until this point here where they actually get right back to their starting point. And it's important to look at how these axes are labeled. That's going to tell you what's happening. If, for example, this y-axis was just distance, well, that graph would never decrease. It could stay the same, where they're not moving, but the distance traveled could never decrease. It would always be increasing. So it's important to read the graph, read those axes to make sense of what's happening. Okay? All right. So that's it for today. I'll hand out the assignment. Won't take you long to do this one, but do it. Check your answers on Google Classroom. Make sure you're doing everything right.